you're looking at long timescale kinds of comparisons. And interestingly as well, you can take all those lines, even though they may be at sort of a characteristic moment, their distribution might be really interesting. So if we're in a really noisy interaction about a TV show I might not know, for example, you would expect to see higher entropy in the distribution of the line lengths than if we both knew the television show and had very consistent, regular, deterministic kind of signal. So the recurrence measures can extract all that stuff. And we haven't done it, but I think it would be definitely interesting to do so. And I should note that Drew, the paper that I mentioned with Drew actually explicitly looks at the timescale issue in some interactive data. So you can talk to Drew after about it. I'll just sort of add some doggerel, and Drew can fix it later if you go talk to him about it. But what Drew did is he took essentially the point process of speech events. So when there's acoustic energy present in the interaction, and so now you have two time series of essentially, complex spike trains, right, of speech between two people. And so if there's indeed this kind of clustering and interdependence over time, what you'd expect to see is some sort of clustering analysis over those. So the technique he uses with Chris is called Allen factor methods. It allows you to compare the clustering present in your observed signal, where interdependence will reflect increased clustering relative to a Poisson distribution that's just purely random. And so clustering would suggest that you are getting like this organization over time between two people. And in fact, what Drew's found is that the clustering, which is beyond what you'd expect from chance, so there is this interdependence, there's like this statistical self-similarity in the signal, that is actually similar between two people as well. So I'm clustered and self-similar, I'm fractal-ish. Drew is self-similar. And then the manner in which we're self-similar actually correlates with each other. But primarily when you're having an affiliative interaction, that effect goes away during argumentative interactions. Is that right? So Drew is sort of actually explicitly tackling this timescale issue in this relatively content-independent way, but it's using these fun dynamic methods that Drew's team can chat about. Anyway, yeah, okay, yeah.
One of the things that was particularly intriguing from your paper with Dorsey was sort of in the discussion, the speculation about the function of synchrony and that it might act as a recovery mechanism for communication breakdowns. I'm wondering if that's something that you would be able to test with your corpus, or would it need to be something where you would have to do sort of a perturbation study to like the team members' communication channel and see that teams that had higher synchrony were more resilient to that perturbation?
Yeah, so there is work on, there's actually a general theory that jives with the description you just gave, which is monitoring and adjustment. And so this monitoring and adjustment theory is actually somewhat controversial because its fundamental idea is that most of the time I'm just going to caricature this theory, but whatever. Most of the time we're just ignoring each other, we're just sort of bouncing off each other, we're not deeply processing what the other's saying. But when we discover or detect that there's some breakdown, then we engage in some sort of recovery process in order to keep the interaction flowing. And actually, there's a wide variety of likely things that happen in such a case. And so achieving some sort of shared or conventionalized referring expression is probably one of those things. So if you and I are trying to find our way through this map and we come across an unfamiliar shape or a disparity between our maps, what we might do is find some way of aligning our spatial perspective. I'm saying, hey, what's on your map here? Right? So we end up coming up with some sort of shared, more abstract spatial notion of the terrain. But then we also might decide on a way to refer to it as well. So we'd say, we run into some sort of communicative problem, and we come to some sort of conceptual or referential pact in order to move on. So I think if we highlight it, and the map task so the Edinburgh group is the one that's done this map task, and they've analyzed this task to death. So every time I sit down with Ellen Bard in Edinburgh, who's one of the leaders on the map task stuff, and every time I show her one of these dynamic results, I have to confess, she just says, yeah, that's exactly like the analysis we did showing that people do this specific thing in this specific context. I said, yeah, but this is showing the temporal structure of it. She says, yeah, but people accommodate. So what? Who cares if it's too, she doesn't quite say that. But the idea is that if you go back and you look at the Edinburgh map task literature, you find that people are actually engaged in a wide variety of strategies to accommodate each other when there's breakdown. And I think in this case, in terms of the initial part of your question, the functional role of coupling or coordination is, I think that's probably going to be part of the story as well. So we could zoom in and look at the errors specifically and find that you might actually, at the moment of error, you might have low coordination, and a few seconds later you might actually get substantially increased coordination in specific channels that might be relevant to that situation. But we haven't done that, admittedly. So Yeah.
Just quickly, is coordination associated with efficiency?
No, you can't say I think, well, I mean, I guess just in terms of just sort of just loosely interpreting that statement, I would say yes, but I think it depends on the task.
In that data, were the people that were more coordinated faster?
So I think that there are going to be different sources of variance present there, and that coordination is going to distribute differentially depending on the specific variable that you're looking at. So in terms of coordination may, in a sort of happenstance way, reflect errors and inefficiency because participants are perceiving, whether it's implicit or explicit, we don't have any such measure, that coming to some sort of more stable interdependent process is probably going to help. That takes place in the context of error, because more errors predicts increased coordination. But at the same time, they're getting better at the task and you're seeing increased coordination. So there are multiple sources of variance that would explain both coordination and the potential performance measures. So yes, I think coordination reflects efficiency, but it also might reflect an attempt at achieving efficiency when there's breakdown, just to sort of follow up with Travis's question there as well. That's what